Hello everyone, welcome to egate.ai. In all the previous videos, we have seen several examples of agents, but we haven't talked about what is an agent program. So in this video, we will talk about agent programs and what are the different kinds of agent program. So when we talk about agent, there are two components of it. One is architecture, another is program. Okay, so this architecture is the sensors and actuators present in the agent, and this program is something which maps the percept sequence to the actions that we have talked already, and we can assume that this program will run on some computing device which will have sensors and actuators attached to it. So if we want to write the agent program for any agent, how we will do that? So for that, let's recall the example of vacuum cleaner world that we had already discussed in our second video. So basically in vacuum cleaner world, there are two blocks, A and B, and there is a vacuum cleaner and there is some dirt. Okay, so this is our vacuum cleaner agent and its goal is to clean the dirt in block A and block B. So we had seen that it has some sensors which can sense the location and the dirt, and it will do actions like it will move to the right block, or it will move to the left block, or it will suck the dirt. Okay, so we had seen a big mapping table for this example. If we will try to write a mapping function for this agent, it would be a function of say position and dirt, and it will map to some action. Okay, so based on this function, if we try to write the mapping table, so if position is A and there is no dirt in this block, so the action would be move to the right block. If the position is A and there is dirt in this block, the action would be to suck the dirt, right? Or if the position is B and it's clean, so it will move to the left block. Similarly, if there is dirt in this B block, it will suck. This is just one percept, right? If suppose the first percept was the agent was in A and it saw that this block is clean, so it will move to the right block. So the second percept would be, so suppose this was the first percept and then the second percept would be B, and suppose if there is dirt in this block, right? So action would be suck the dirt. Or suppose if this was the first percept and when it goes to the second block, that is also clean, now it will move to the left block. So basically we have to write the table having all possible percept sequence and corresponding action for that sequence. Okay, so if we will try to write a agent program, how will it look like? So I have written the function for this agent. So we are calling it table driven agent because this agent is based on this big mapping table. So it will get the percept. So it has to store two things basically. One is the history of all the percepts, which will be empty initially, but as we will go with time, this will increase, right? And other will be a storage for this table. Okay, so how this simple agent program is functioning, it is getting a percept every time. It is appending the percept in the percepts array or list, and then it's simply looking in the table, okay, with a given percept sequence, what action it has to take, and we are returning that action from this function. So this is very simple and very naive program to return actions for all possible percept sequence. Okay, so what is the problem with this agent program? So basically the biggest issue is the size of the table. Okay, because you have to write the entry for all possible percept sequence in this big table, and it would be impossible to store this big table, right? So let's try to understand how big this table would be. Okay, so for just one percept, okay, so the agent initially can be either in block A, in block B, and if it is in block A, it can be clean or dirty, and similar for if it is in block B, right? So there are 4 possible action for just one sequence, right? So number of possible actions are 4. So there would be 4 entries for one percept sequence, right? Let's consider second round of percept. So for second percept, suppose this was the first percept. So corresponding to this first percept, there can be four entries, right? B can be dirty, B can be clean, or next could be A clean and A dirty, right? So if initial percept was this, corresponding to this, there can be four entries for the next percept. And then this first could be A is dirty, B is dirty, B is clean. So there are four possibilities of first percept also. So how many actions would be there? There would be 4 cross 4, 16 actions, right? So for second percept, how many total entries would be there in the table? That would be 4 plus 16, right? So this table will grow. So for the tth percept sequence, the number of actions would be how many? 4 into 4 into 4, that is 4 to power t. So how many total entries would be in the table? It would be 4 plus 16 plus 4 to the power t. So we can write it as sigma t 1 to t and 4 to the power t. 4 is the possible set of percepts. So we can derive a formula here that for number of entries at time t would be p to the power t, where p is the number of possible percepts. So you can see that even for this simple vacuum cleaner world, the number of entries would be too many, right? So this is practically impossible. So what we will do that? So we will use some techniques, some tricks, so that we can reduce the number of entries in the table and we can take more intelligent actions. To reduce size of this table and to take more intelligent actions, we have different kind of approaches that we will discuss in the future videos. There are reflex agents, then there are model based agent that we will discuss in the coming videos. Thank you so much.